Goggles for safety, of course. Alright, this is my oil and water experiment, and what I'm going to prepare for all the students, they'd be in small groups. I would have a jar full of about this much water. It could be about a third full. I didn't have quite that much. But anyway, first you would put some food coloring in the water. You could have the students do this. Just a few drops, just till you get some color to it. That's just going to help them tell the difference between the water and the oil. And then after that, I would have them add the same amount of oil to the water. So it doesn't have to be measured, just roughly the same amount. Alright, and then we would talk about how they won't mix together, how the oil and the water kind of repel each other, how for whatever reason they won't mix together. And you could have the students brainstorm reasons why they think that might be. And then we would have them screw the lid on tight and try to mix it. See if they can mix it. Shake it as hard as they can. Alright. Now, it looks like at first that it's mixing together, but then after a while, they'll notice that no matter how hard, how long they shake it, eventually the oil and the water are going to separate. Okay? The oil got a little bit of red in it from the food coloring, but other than that, you can clearly tell that there are separate layers. The oil being on top and the water being on the bottom. And you could have the students make observations, and then here you can maybe talk about why the oil would be on top, and you could talk about density and how the oil, and this is just corn oil right here, it could be vegetable oil, any kind of oil really, cooking oil. You could talk about how the reason that the oil is on top is because it's less dense than the water. And then maybe you could also talk about how the water and the oil molecules don't mix together because water molecules are very attracted to one another and the oil molecules are very attracted to one another. And so they don't like to mix together. And then you could have students brainstorm ways as to how they could get them to mix together, if they think they can come up with anything. And eventually, you could show them this. Soap, dish soap, it's just regular dish soap. Just put a few drops in there. That's all it takes. I'm going to shake this over the sink this time. And then if you look at this, the oil and the water have clearly mixed together. It's all one uniform substance. So, the students should notice that they mix together. And this is where you would talk about the process of emulsification. That's what's happened here. Emulsification has occurred. And I found this article on the internet that you could read with kids and you could talk about. And it says oil or fat is hydrophobic, and hydro means water, and phobic means fearing, so fat or oil fears water. Water is hydrophilic or water-loving. So the soap molecules are amphiphilic, which means that they love both oil and water. Specifically, one side of the soap molecule likes water, while the other likes fat. So the soap molecules arrange their hydrophobic ends around little droplets of fat molecules, while their hydrophilic ends point out towards the water. This arrangement allows the fat to coexist with the water. And this demonstration can help explain how soap lifts all that greasy residue in your pots and pans after you make some greasy food with oil. The soap's hydrophobic ends help get the oil droplets into the water so that they can be washed down the drain. And then you could talk about how this process right here, the term for that is emulsification, and the soap is an emulsifier. And then maybe you could extend that and talk about how there are other emulsifiers other than just soap. It gives an example here. There's an ingredient in a lot of salad dressings and chocolates, food with fats, and the emulsifier they use in those is called lecithin. And the reason they use that is because it it doesn't have a bad taste. Obviously, you wouldn't use soap in a salad dressing or chocolate because you would taste the soap. So that's my lesson on oil and emulsification.